Hello friends, welcome back. And today we're reviewing a note which I prepared for Oracle Database Performance Tuning. So it's not for Oracle Database Performance Tuning. So what based on my experience, like when you interview. So the favorite topic for any good company is database performance tuning. And before you can answer a random set of questions thrown by somebody good at it or maybe average at it, you need to know. And there are few things which are like quite common, like 1 hour interview. So the first 30 minutes will be in and around for the short things which you need to know, and this is an attempt to get you through what are the things which you can cover out of most of the items. And this has been researched and pointed out, not pointed out, this has been researched and made a note at my end and to make you that before you go, you should know something. Okay, so let me, yeah, okay. So first of all, you need to know different type of joins, which is important, and how this join works in. Okay. You also need to know five Oracle database performance scenario. So if somebody asks you like a database performance scenario, start to end, you should be able to answer it. You should know the performance tools. You should know how to generate AWR report, ASH report, ADEM report, and you should also know that how to read these things and where these are important. So, for example, ADDM reports will give you the general findings. It actually take a data from AWR report and gives the it stands for automatic diagnostic database monitor. So it will basically gives you set of the recommendation that you can put it on your database and get some better performance. But based on my experience, I have not seen typically ADDM reports being used. To be very frank, and the people either generate an AWR report or a ASH report to analyze it. So ASH report is more towards on the time when you have some incident going on and you need some point in time at the level of 1 minute. So it will give you more granular reports. What is happening? AWR report is a it's for a duration, for 30 minutes or whatever the snapshot ID you have. So it won't make you to go drill down at the very lowest level, and it will generally help you to understand overall that how the database is performing. But ASH report is something which you should look for if you want to find the root cause of issue. Now, okay, moving to next, you should know about the partitioning. Generally, like hash partitioning, range partitioning, and a hash range partitioning. You still need to know red devices, red 0, red 1, red 2, I think red 0 and red 1 and red 5. Real life performance issues, that's what I hear. 5 Oracle database performance, real life. So you should know that, what are the real life performance scenario. So see, practically you would not be doing it, because if you are doing that part, you would actually not would be viewing this video right now. So nobody does that. Okay, to be very frank. So you have to gather those info. You have to know undo table space analysis, how the undo table space works. That is still very Then you need to know database internals like how what is SGA, PGA, TAM, sorting, and deadlocks, NQ, PCT pre, PCT use, high watermark, and log writer, DB writer. Okay, so you should know this thing. Checkpoints. Then how to fix common wait points, wait events. So there is a two-way to understand it. One is that you actually understand what these wait events are, and then you can practically correlate. Hey, for this I need to do this. So let's say, for example, if there is a buffer busy wait, so what does it mean? That the buffer is busy. So the data block which one application want to read from buffer is being acquired by somebody else, and that's why the buffer is busy. So if there is a much of buffer busy wait, you need to understand that. Why? How could you reduce? How could you remove that weight? Okay, and in which sequence the requests are being sent in order to read those requests. So you have to remove this. Then you have to know about the SQL Tuning Advisor, SQL Access Advisor. So what is SQL Tuning Advisor does? It's actually advise you how to tune your SQL. Access Advisor will give you the alternative plan so that you can understand if you have so it will actually give you two plan. One is one two plans, and you have to analyze like which one you should use so that you can get a this thing. So database replay. So database replay is like taking a copy of the database in the test environment and moving to another environment with some better configuration and checking how the load is working out. SPA is called a SQL Performance Analyzer. So what happens? You have your production box running in one environment, let's say Linux. You generate the first part of the SPA steps there. Basically, what you do, you create a SQL stats, then you export it as a dump file. You move it to your pre-prod, let's say hexadata. You import that dump file into that hexadata, right, machine, and then you generate your reports. So basically, when those reports are generated, basically we generate three: unchange, change, and basically we want to see in those reports what are the SQL that basically the unchanged one will see. Unchanged one will generate that how the SQLs are relatively performing without getting change at the optimizer level. So the optimizer interpret the SQL the same way, and you check for the regression. Okay, so if it's some queries are regressed, so what does the regression mean? Regression means that this, the Oracle has to change this query internally in order to get you the output. So in that it regressed. That's a keyword. In the change one, it will give you the list that hey, these are the SQL which has to which will get changed in on the base in the execution phase, and then you have to check for the regression. So you have to make sure that none of your queries get regressed, and it will give you the percentage highlighted in a green. Okay, so you need to know what are the ways you can gather the stats. So you can gather the taste stats at the schema level, at the table level, then histograms stats. So histogram is like let's say you have 100 rows, 100 values. So out of 100, there are like 20 unique values, assuming 20 into 5 is 100. So if you gather a histogram stats, so in those 100, those 20 unique value for one, let's say you have a 20, so you have a 5 into 20. So those 5 can be in the any row from 1 to 100. So if you have a histogram, it will segregate those entry stats, okay, histogrammatically. So it will make your process fast. You should know how to generate the trace. So you can generate the trace at the optimizer level by setting 10053. Generally, it's not recommended because it's a big 15 to 20 MB of file and what you will read it. And there is a 10046 for a SQL. So in that, you get the information about the SQL, which is like what is execution, parsing, fetching, and the other stats. You need to know what is a baseline. So, and then AWR compare report. So baseline is like, let's say for an example, I have an optimum performance and I can decide a person. Baseline can be defined by anybody. There is no simple formulas. So I say okay, at 11 a.m., 100 users functionalities, 100 users accessing my system, and whatever the stats gets generated is my baseline. Now that is defined. Okay. So, and then I can run a compare report to see the difference between the two period. Then I need an indexes and a materialized view. So materialized view, how it works, basically instead of making a query to the table directly, I actually query the view. And materialized view have an option where my results can be refreshed at the real time. Okay, so real time is like if there is a change in the parent table in the backend, the materialized view will have those details in the real time or based on the settings for that, so that when I query the materialized view, it will not trigger the backend. So it will not touch the tables where the actual data is. And then you also need to know new Oracle database feature. So you need to know how the database from the 12c 1.2 gets changed to 12.2 to 18c to 93. One example can be when the database was in 12.1. At the PDB level, if you're cloning the PDB outside a CDB, you will be able to create a standby in a simple way. But as they move to 12.2, they remove that feature. Okay, I don't know the reason, but yes, it was. So you need to know, understand on a different area, like preferably on a SQL area, based on your job requirement, that these are the something. Okay, then these are the important type of indexes: B tree, bitmap, function based, partition, and a reverse key. So just the B tree. Okay, it will be like this tree structure. Okay, bitmap is like 0, 1, 1, 0. Function based is like if you write some, okay, then these whole thing gets stored. Partition index is for partitioning. Reverse is like, instead of going from left to right, it will go from right to left. Okay, so let me remove this. Okay, now you need to know data modeling. Okay, that how do you normalize your query? So normalization is basically remove the redundancy so that you do not end up storing the same record in a different table in order for, and also to maintain the data integrity. So you need to know in which scenario normalization 1, 2, and 3s are created. What are the top 10 mistakes? One is a bad connection management. You're using the frequent commit, or you have time to disconnect set high. Okay, so although you completed your work before, but you're not releasing the connection. Bad use of a cursor in a shared pool. It means you're not using the wind variables. You're hard parsing all the queries. You're okay. Then you're writing the bad SQL. Use of a non-standard initialization parameters. So what does this mean? That you're not using your at the DB level, the parameters are not basically optimized. Okay, database I wrong online. Okay, you have a less redo log group so that the system checkpoints increases. So you have to optimize your redo log groups. Long full table scans are happening. High amount of recursive SQL. Okay, deployment and migration issues that you need to know. You need to know how the resource manager works. Basically, what happens that with the help of resource manager, you can allocate the resources, CPU memory on the basis of services. Okay, so you need to understand that dispatcher wallet comes in a picture of when you use transparent data encryptions. Arman is for the backup. Remote management framework that you need to know. Performance hub active report. So this is the new feature in OEM 13.3. So once you log in, you have a performance hub report. So which will give you what's happening in the database at that particular point in time. Okay. Then you need to know about the DB processes. Maybe you can enroll doc ID. Okay. You can DB processes, you know, what is the foreground process, what is the background process. So for few of the processes, it's very common, like MRP01 used for setting up the replication service. Then you have a DBWR, and then you have a log writer process. Then yes, then you have an armament process and also to go. Okay, you have to understand how Oracle database concurrency control works, how multi-versioning work, and then how SQL. So SQL plan management that can prevent performance regression, and also you have to learn SQL performance. So you need to know how SQL plan management works. SQL tuning set is a database object that includes one or more SQL statements along with their execution statistics and execution context. Okay, so this is a part of the SPA. You create your SQL tuning sets, which includes one or more of a SQL statements along with the execution. So ADDM and advisor use automatic AWR, which is an infrastructure that provides service to, okay, ADDM analyze AWR to determine possible performance and including high low. Okay, so is the internals of the database problematic SQL is on how to improve statement performance. So SQL Tuning Advisor is an diagnostic software that identifies problematic SQL statements and helps how to improve the statement performance. Okay, and then there are for the details. You can just okay how it works out. So it checks for the missing a stale. It builds SQL profile, and then okay, so it goes like this way. Okay, so you can learn it. And what is the accessor? Is a diagnostic software that recommends which materialized view log to create, drop, or retain. Okay. Our indexes. So SQL Access Advisor. So see, that's what I say. Access means it will tell you about the access path. So access path is like indexes materialized view. So it will tell you which to key, which to remove, and how it does it. It takes an actual workload as an input, or the advisor can derive an hypothetical workload from the schema and consider trade-off between space uses and query performance and recommend the most corrective configuration. Okay, this is about how automatic indexing works. Automatic index management solves the problem of mental performance. It monitors the workload, it creates the new indexes, it rebuilds indexes, then marks them usable and invisible. It drops the indexes, change the effect of automatic index management on performing the index feature, and implement as an automatic task that runs in the background at a fixed interval. So basically what is happening, it will do some analysis on the index parts. It will do the rebuild, it will drop it, it will monitor the workload constantly, it will create the new index, it will yeah, and check the effect of automatic index management. So you need to actually understand it. So what is create a set of candidate indexes, consult a prioritized compiles, performs either of the following actions until that point would improve. It will do all the things. So just read it. Let's read it. So it says automatic index management solves the problem of manual maintenance by performing the following tasks. Basically, it helps to solve the manual maintenance. It monitors the workload constantly, creating a new indexes, rebuilding indexes, and then making them usable or invisible. It dropping the indexes, checking the effects of automatic index management on performance. The indexing feature is implemented as an automatic task that runs in the background at a fixed interval. At each iteration, the task performs the following basic steps: identifies index candidates based on column and column group users, creates a set of candidate indexes in unusable and invisible mode. These indexes do not occupy storage space. Consult a prioritized list of previously executed statements to determine whether the candidate indexes are worth rebuilding. Compiles the statements to determine whether the optimizer would choose the new index and then rebuild the index that the optimizer chooses. Execute statements that uses the automatic indexes, performs either of the following action, marks indexes as visible when the statement would improve its performance significantly. The database changes plans for the statement in the workload only after verifying and marking the indexes as visible. Until that point, the database does not invalidate cursors and continues to use old plans, marks the indexes unusable when they provide insufficient performance benefits. This action occurs in a deferred manner when the probability of using the index for other statements is low or when there is a space pressure. Avoid regression by using the SQL Plan Management. An index may benefit one statement but cause a performance regression in a second statement. In this case, the database optimizes the first statement by marking the index visible. To prevent a regression for the second statement, the database protects it with a SQL Plan Management. Drops indexes that has not been used in a long time. Creating indexes manually requires deep knowledge of the data model. Okay, so how do you enable automatic index? You execute auto index configure, auto index implement. Okay, now SQL Plan Management is a preventive mechanism that enables the optimizer to automatically manage execution plans, ensuring that the database uses only known or verified plans. This mechanism can build a SQL plan baseline which contains one or more accepted plans for each SQL statement. By using baseline, the SQL plan management can prevent plan regression from environmental changes while promoting the discover and use better plans. Okay. So basically, it's all about the plan manager, which is also called SPM. So in that, what happens then that so which enables optimizer to automatically manage execution plan that the so that the database use only known and verified plans. This mechanism can build a SQL plan baseline which contains one or more accepted plans for each SQL statements. By using baseline, SQL planning will prevent plan regression from environmental changes. Okay, so these are the important V dollar active session history. Okay, so it keeps the detail of active session in a history. V dollar session is the current one. V dollar session long ops is for checking what is the current status of some processes running. V dollar SQL has the detail of the SQL. V dollar SQL plan has the detail of the SQL which is currently in a cursor. Okay. Then you should know how to generate generate the SQL trace file by setting 1046. Then with the TKF prof, you can format it and then you need to know about the TRSS. Then you need to know an example of data modeling, how the data modeling is done. So when I say a data modeling, it's all about that you get a business requirement and then you design a database tables and establish the correlation and normalize it. That is called a data modeling. The important thing is to apply greatest modeling effort to those entities for the most frequent business transactions. So the rule of the game is that you have to apply the data modeling technique to those transactions which are most affected by a business. Then you need to know what are the modeling tools. Okay, and okay, so we'll stop here and then we will switch back to the next video and we'll go furthermore. So I have like a 35 slides which is like shared pull check and then how the shared pull check happens, what are the optimizer modes, and what is the cache fusion algorithm, Oracle support, then crctl command, and then some of these utilities. And this is about the Oracle cluster registry. Then what is the ASM stripping? We'll talk, and then how it happens 1 2 3 you create a file and ASM storage, basically about the rebalancing I think. Then you have flex cluster and these are the system parameters, how do you set this, then Oracle cluster registry, voting disk, then how a rack cluster processor starts and stops, this is important, and what are the tool you have to manage an OCR, and then what is the GNP profile and the ASM profile processes. Then how do you set the ASM power limit and what is the use of it? And remote login password file. Then rack diagrams. So you need to understand GCS and GES, which is important, and then rack specific processes like LSM, LMON, LMINT, ACMS. You need to understand, and then yeah, difference between logical and the physical operations. Then you have a file system options here. What are async, direct, and none? Then about the SGA components. Then about the tables. How do you do your session tracing? And then how these things works, like advisor part, how it works and what is the correlation, then the histogram, what is the wind sensitive and wind aware, and then high watermark, then what is the definition of full scan, fast full, concrete, and sudden fail, PC tree and PCT use. And I think so. We will cover this. I mean to say, like the more we discuss, it makes your fundamentally it more clear. So this is the way we learn it. So we'll just stop it here, okay? And we'll go.